Hi, this is a short video about random numbers. So it might seem that random numbers are pretty straightforward. Sometimes when we are making a game or want to sort something randomly, mix it around or something like that, we would want to use random numbers for achieving that. The only problem is that our computers are really deterministic in nature. So there's actually no random numbers in the computer at all. So we cannot generate random numbers on computers. It doesn't really exist. So this video is shortly about what can we do about that and how has that been solved. And when is a number really random enough for usage in our program? So I started with this small cartoon here where we have someone saying over here we have our random number generator, and the random number generator just says 9999. Are you sure that's random? That's the problem with randomness. You can never be sure. So how can you be sure if something is random? That's not really easy, because if it's random, there's no pattern. So you kind of have to find out if there is a pattern. So if you don't find a pattern, it doesn't mean it's not there, just means you haven't found it yet. So it's kind of, you have to prove that something isn't there. And that is really hard because you have to consider almost everything, but there are things you can do. Okay. So what is random, and is anything really random? So sometimes some things seem random, like when you throw a dice. It looks like the outcome of that dice is truly random. There certainly isn't any way we can predict what comes out of the dice. So in that way, if it's a good dice, it should be random. If we imagine that there was some system to dices, then we would know that we could predict the outcome in a casino or something like that, and no one can do that. So is it random or isn't it random? Maybe the pattern is just too complex for us to calculate. Maybe the physics involved are too complex, or maybe it's truly random. Who knows? So it's more like a philosophical question if anything is really random. Do you believe it's random or not? Does anything happen by coincidence, or is everything predetermined? So that is a bigger question I'm not going into in this video. So there are different ways of creating random numbers, and one of the simplest ones is just to do a new random number with this formula that you see here in point 3. So with this calculator, we kind of square the numbers and then we take the middle ones. So let me show you. So if we open up the calculator, so we'll need to start out with some number that is going to be our start number. So this is what we call R0. This is the initial seed value. Probably heard of this seed before. So the reason why we need a seed value is because we cannot get a random number from the computer. So we need to feed it some input for it to calculate the random number. So it's kind of problematic in some ways that we need to feed the computer with a random number for the computer to generate more random numbers. So we are really not solving the problem, we're just moving the problem. So if the seed is not random, the number is not random. So let me show you. So let's take some number, like let's start with 45. And then we square that to get the first number. So what this does is we take the middle of that number, and M defines how many digits are we going to take from the middle. In this case, it could be 0 and 2 if it's 2 digits. So that means that our our next random number will be 2, and we square that, and then it's 4, we square that, and 16. So we may have started out with too small a number. Let's do something else. So let's take a larger number like 7, 4, 5, 8, 6, 2, for example. And we square that, and then we take the 6 middle digits from that. 3, 10, 1, 2, 3. And we type that. And we square that, and then we get this number, 176275. And we square that, and then we take that number, and so forth. So in this way, we'll keep getting something that looks like a random number, except this random number generator isn't really working out that well. If you look at the numbers more closely, it will not create very good random numbers. It will not be have a very good distribution, normal distribution, if you look at what you would expect from something like a dice instead. So it's a really bad way. It's just to show you one way that we can start out with one number and then get a whole list of numbers from that seed value. So this is basically how random numbers work. We put in a seed, we do some magic math on that, and then we get out the next number, and based on that number, we take the next number, and based on that number, we take the next number, and so forth. So what really makes out a good random number? So what most programming languages are using, they're using something called linear congruential generators, and they look like this. So what really happens here is also the same as in the other formula, but it's a bit different. So it works the same as the other one, it's just a different formula. So we start out with some seed like we did before, which is x0. In the other one, it was r0. We go back. It was called r0. In this case, it's just called x0. So we start out with x0. It could be some number. So we take our calculator and we take that number and we multiply it by another number and then increment it by another number. So we have two constants here. We have a and c. These are both constants. One of them is multiplied by the number, and the other one you add some constant to the number. And then you use modulo or modulus to take the rest of the division. And this works a lot better than the other one. This actually gives some very, very good results, and to most people it will be all you need in order to do this. There is some requirements though. You have to be careful which numbers you select. Obviously, if we select 1 here, then this becomes the same as x, and we select 0 here, then it's just x. So then it won't work very well. So we need probably to have some quite big numbers in order for this to work well. So if we look into different programming languages, I found this nice little table here. We can see that a programming language like Java, util random, it has the value m. The modulo is 2 to the power of 48, and the multiplier is this big number, and the increment is 11. And then it also picks out only some of the bits. So it takes out only, the output takes some of the bits, it looks bitwise on this and takes out only some of them. They found out that worked better. So formally, they used something called randu, which used this number here, and it didn't have an increment. And I'll show you what the problems are with this. But you see, all of these are using the same pseudo-random number generator, which is called the linear congruential generators. And some of these are from books. So these are different values. And these values are taken because they've looked at the numbers that came out of this and seen some problems, tried to fix them by adding something here or here and so forth. So let's try to look at some of the outputs of these congruential generators. So this is a hyperplan of the linear any linear congruential generator, and we see at first it seems like they're spawning at random, but as we get more and more into the plane, we see they kind of form these lines, and this is the linear nature of these algorithms. Here I created these images because it's hard to see the randomness. If we look here, this is in Danish though, but here I took, for example, this is Java lang util. And here I took and made a virtual dice, and I did like 1 million throws of the dice. Or 10 million throws of the dice, and then I tried any random number between 1 and 10, and we see that in Java lang util, when I counted the number of ones with 10 million dice throws, I had 1,052,000. So we would expect this to be close to 1 million, and the deviation is very low. This is the deviation in percentage. It's very, very low. It's a very low deviation from that number. So we would expect all of these to be around like 1 million. This is why I chose 10 million. It's easy to see if it's close to 1 million. If we look at Randu, for example, the deviation is bigger for some of the numbers, but it's actually doing quite fine, this algorithm Randu, which was the old one without any increment. If we look at something like the max deviation here was 0.025, and here it was 0.094, which is the sum of all the deviations, we see that Java's is doing better than this one. So if you go back, we can see that Java uses this large number and 11 as the increment, whereas Randu uses this small number and 0. So this does perform worse, and also it doesn't do the bit part. If we look at something like Pascal or Delphi that uses the same here, we can see that the max deviation here is actually almost 6% for some of the numbers. So for example, the number of 4s has a big deviation, and the sum of all deviations, Pascal is actually the one doing worst. We see the C++ generator is also not very good. And we see this is from a book called Numerical Recipes that does a bit better, but actually the Java deviation is actually better. So Java is actually the one doing its best here. I must say though, I used this seed, and for some of these languages, there are actually requirements for the seed that it cannot be this small of a number or something like that. So some seeds won't work very well with them. I haven't added this into the equation, so it might be different for other seeds. I know especially some seeds will work very poorly with Randu. So this is just an example of one seed we could do. These would change with each seed, right? But they would always be the same if we have the same seed, because it's a pseudo random number generator. It takes a seemingly random number and creates new numbers from that number. So yeah. So that's basically, I wanted to show another thing. So if we look here, I actually took all the numbers and I plotted them into this array, double array here, and I colored it by so the more times that the number would land on something, it would actually color it more. So the more black it is, the more times it reached that number. And we can see this kind of linear nature for all of these. So they look more or less random. But what is interesting here is that we, with the human eye, are very, very good at spotting patterns with the human eye. So what we can see here is we can clearly see a pattern for all the programming languages. We can clearly see that this is not random. If I asked you, are these images created by random? You would most certainly say no. There is a big pattern. Of course, they are symmetrical along this line here, but other than that, there is clearly a pattern in all of them. You see, Java, interestingly, looks a bit different. It looks more random, but we can certainly see there are some things that are actually being reproduced in this algorithm. So none of them are really random, but if you look at the pure statistical distribution of them, Java looks brilliant. But when you look at it like this, there's clearly a pattern to this. So we are not really generating real random numbers here. We are generating something that's close to random numbers, and they're never really random because they are all based on the same seed. So if we can actually guess the original seed, we can guess all of these numbers. Then we will know all of them. So I think it's kind of an interesting thing that we can look at the statistical distribution and see that it looks fine. But when we plot them into an image, it becomes very evident that they are actually horrible for doing randomness. So if you're going to create something like an online casino or going to create something that has to do with security where you need real random numbers for some security algorithms, you most certainly cannot use the basic random generators of your uh, preferred programming language. Of course, some of this is not really it's not the best test in the world. It's more just to show you the problems of um, of these kinds of algorithms. And in the next video, I'm going to show you how to use random the random generators in Java and what to be careful when using it so that you won't get into problems. So that's it about random numbers. Bye.